All right, so let's continue our review. All right, so here we have the number of bacteria that are in a petri dish after T hours. So anytime you have a word problem, make sure you understand what each variable represents. So here the T represents hours. So after T hours, there are this many bacteria in the petri dish. So I plug in the number of hours for T, and this function will spit out the number of bacteria. All right, so what I want to know is what is the percent change of bacteria per hour? All right, so is it a 70% increase, 70% decrease, 30% increase, or 30% decrease? So pause the video, see if you can figure that out. All right, so let's just plug in some numbers and see what happens. So after 1 hour, let's start with 0. So let's make a table. Hours and bacteria. So after 0 hours, how many bacteria are there? So plug in 0. 0.7 to the 0 is 1. 1,000 times 1 is 1,000. So we start out with 1,000 bacteria. After 1 hour, so put in 1. 0.7 to the 1 is 0.7. 1,000 times 0.7 is 700. So we see that the number of bacteria are going down. Let's try 2 hours. So if I put in a 2, 0.7 times, 0.7 squared would be 0.49. 1,000 times 0.49 would be 490. And let's do one more. After 3 hours, 0.7 to the 3rd power, so I'm going to get out a calculator here. 0.7 raised to the 3rd power is 0.343 times 1,000 be 343. All right, so right off the bat, we can mark out 2 of these. The number of bacteria is obviously decreasing, so it cannot be that, and it cannot be C. So it has to be either 70% increase, 70% decrease, or 30% decrease. Well, that's pretty easy to figure out. So if I'm going from 1,000 to 70, 1,000 to 700, I went down 300 bacteria, right? So I've decreased by 300 bacteria. 300 is 30% of 1,000. So I have decreased by 30% each time. Right? So I went down by 300. 300 is 30% of 1,000, so I've decreased by 30%. All right, here's the next question. So the graph of y equals x to the 3rd minus 7x minus 6 has a 0 at x equals negative 2. Remember, 0 is synonymous with root, so it has a root at x equals negative 2. Which of the following is also a 0 or a root of the graph? So multiple choice, pick which one of these is another 0 of the graph. So pause the video and solve that question. All right, so let's work through this and let's pretend like they didn't give us any answer choices to choose from, that we had to figure it out. So we know that one of the roots is x equals negative 2. So I know that x plus 2 is a factor. Okay, so x minus 2 is a root, then x plus 2 has to be a factor of that graph. So I can divide x to the 3rd minus 7x minus 6 by x plus 2 and see what I have left. And let's fix this up a little. I'm going to put the x squared, the missing x squared term in there. So x to the 3rd plus 0x squared minus 7x minus 6. And that's just for bookkeeping purposes so that I can keep everything straight. So how many times will x go into x to the 3rd? Well, it'll go x squared times x is x to the 3rd. X squared times 2 is plus 2x squared. I need to subtract. Those cancel. That'll be minus 2x squared, bring down to minus 7x. How many times will x go into minus 2x squared? Well, it'll go minus 2x times. So negative 2x times x is minus 2x squared. Minus 2x times 2 is minus 4x. And I need to subtract all of that. Those cancel because that becomes a plus. That becomes plus 4x. So negative 7x plus 4x is minus 3x. Bring down to minus 6. All right, x into negative 3x will go minus 3 times. So minus 3 times x is minus 3x. Minus 3 times 2 is minus 6. Subtract. And I get a remainder of 0. So true enough, x plus 2 was a factor of that because it went into it evenly. So I have x squared minus 2x minus 3. I can factor that. I need a 3, a 1, minus, and a minus. All right, that factors it. So I want to find the 0 of this. Okay, I want to find the root. So what we've done, we've set this equal to 0. So if I multiply two numbers together and the answer is 0, then either x minus 1 is equal to 0 or x minus 3 is equal to 0. So either x equals 1 or x equals 3 is a root. So I know all three roots. My roots are negative 2, 1, 3, and according to this, that would be this one. All right, so hopefully you all caught my mistake here. I made a silly boo-boo. So this does not factor like this. I need two numbers multiplied to get negative 3, so my signs are going to have to be different. And negative 1 and minus 3 does not add up to negative 2 anyway, so this was silly on my part. I was going way too fast. I need to slow down and pay attention. All right, this will factor as minus 3 and plus 1. I have to do a much better job there. All right, so let's double check. So that's x squared minus 3x plus 1, that's minus 2x, it's minus 3. All right, so I'll have x minus or x plus 1 equals 0. So my answer will be x equals negative 1. And then this one, right, or x equals 3. So actually we should have both of these being roots of the graph. All right, I went really fast on that, so let me back up and try to go a little bit slower. So we want to find the roots of the graph of 0. So anytime you want to find the roots, it's very important to say it equals 0. That's what root means. You want to know, when does this equal 0? Where does it cross the x-axis? So 0 equals x to the third minus 7x minus 6. Okay, so anytime you're asked to find the 0 or the root, this is what you're doing. You're setting it equal to 0 and solving. All right, we know that one of the roots is x minus 2, or x equals negative 2. So we know that x plus 2 is a factor. Okay, so we know that this is going to factor as x plus 2 times something else. Right, so x plus 2 is a factor, so x plus 2 times some other polynomial. So we did this division to figure out what this was. So this factors as x plus 2 times x squared minus 2x minus 3. Right, that's what it means to be a factor. And we did this long division and it all checks out. If this divided by x plus 2 is that, then this times x plus 2 has to be that. All right, and then we factored this some more. So we had 0 equals x plus 2 times x Make sure I did it right this time. Minus 3 and plus 1. All right, so this thing, this polynomial, factors like this. So then, if I multiply numbers together, and the answer is 0, then either one of those could be 0. So either x equals -2, or x equals -1, or x equals 3. So those are my 3 roots. So 3 and -1 should be roots. All right, but this is a multiple choice test. So did you really have to go through all of this to get the answer? No, you could have just went down the list and found out which one were roots. So is 0 a root? So all you have to do is plug 0 in for x. So if I put 0 in for x, I get 0, minus 6. So when you plug zeros in for x, you get y equals -6, which is not a root, so that's out. If I put in 3, 3 to the third is 27, minus 21, that would be 6. 6 minus 6 is 0, so that really is a 0. I can put in the 2. 2 to the third is 8, minus 14 is minus 6. Minus 6 minus 6 is -12, which is not 0, so that's out. I can put in a -1. -1 to the third is -1. And if I put a -1 here, that would be plus 7. -1 plus 7 is 6. 6 minus 6 is 0, so that is a root, and everything checks out. All right, so here's a really easy question where you are multiplying 2 complex numbers together. So multiply 5x plus 3i and the conjugate of 5x minus 3i. So pause the video and work that out. All right, so I'm multiplying 2 complex numbers together with imaginary parts. So let's do that. So 5x times 5x is 25x squared. 5x times -3i is minus 15x I. Try again. So 5x times 5x is 25x squared. 5x times -3i is -15xi. All right, and then I have plus 15xi. And then I have minus 9i squared. All right, and just like always, when you multiply 2 conjugates together, those middle terms are going to cancel. And I'll be left with 25x squared minus 9i squared. All right, and then the really important part to remember when dealing with complex numbers, remember that I is equal to the square root of -1, and also remember that I squared is equal to -1. So very important, the definition of I. I is the square root of -1, so I squared is -1. So right here, I can put -1. So I have 25x squared minus 9 times -1. So this will be plus 9, so I'll have 25x squared plus 9. All right, so here I've given you 3 different scenarios, and I want you to match the scenario with one of these. So one of the scenarios is an experiment, one is an observational study, and one is a sample survey. So here's the scenarios. So in the first one, Jack stands at the corner of the math hall, and he just counts the number of students that walk by. And out of all these, he notes the number wearing hats. Okay, so he has the total number of students coming by, and he also notes the number wearing hats. All right, in the second scenario, the teacher asks all the students in class to, we'll say, anonymously answer the question if they often wear a hat in the hallways. So she'll know the total number of students in that class, and she'll note how many answer the question that they wear hats in the hallway. In the third situation, Jill's going to stand out in the hall, note the number of students that come by, and also the number that come by with hats. She'll have that percentage when no teacher is in the hallway. On the second day, then, she's going to have Mr. Briscoe stand out in the hallway. And then she's going to do she's going to note the same number. She's going to count the total number of students that come by, the total number wearing hats with Mr. Briscoe out there, and she will compare those 2 days, the numbers on those 2 days. So which is which? So first of all, an experiment, you have to manipulate something, okay? So this third one is going to be the experiment. She has a control situation where there's no teacher in the hallway, and then she's going to manipulate it by putting Mr. Briscoe out there, and she's going to compare how Mr. Briscoe's presence affects the control situation where she had no teacher in the hallway. So by doing that, she'll be able to tell how Mr. Briscoe's presence affected the hat wearing. Probably there were a lot less hats with Mr. Briscoe standing out there. All right, which one is the observational study? So an observational study is where the studier just observes. They don't change anything. So that would be number 1, where Jack is just standing at the corner and all he does is observe what's going on. Doesn't change anything. All right, a sample survey. Well, that's just what it says it is. You survey a group. So the teacher gives a survey out to their class and tries to figure out how many students wear hats that way. So number 2 would be the sample survey. All right, so here is a system of equations. I want you to solve that system of equations. Tell me what x, y, and z are equal to. All right, so there are all kinds of different ways to go about this. I'll start off. I see an x here and an x here, so it looks really easy to eliminate this x. So let's get rid of the x. So I'm going to come over here to x plus y equals -2. And if I want to eliminate the x, I need to multiply both sides of this second equation by -1. So if I do that, I'll have minus x minus z equals -6. And then I can add those together. So when I add those 2 equations, the x's cancel, just like I wanted. And I'll have y minus z equals -8. All right, so how did that help me? Well, now I can make a substitution into this next, well, maybe it'd be easier not to even substitute. So now I have these 2 equations. I have y plus z equals 2, and I have y minus z equals -8. So let's not use substitution, let's just use elimination again. So I'm using the third equation, y plus z is equal to 2, and I'm using y minus z is equal to -8. If I add those together, I'll eliminate the z's. Z minus z is 0, y plus y is 2y equals -6. So now I can solve that for y. So y is -3. Awesome. So I figured out one of my variables. All right, then it should be really, really easy to figure out the rest. Once I know y is -3, I can plug that back into any of these equations I really want. Let's just put it in, I don't know, right here looks like fun. So if I put -3 in for y right here, I'll have -3 plus z is equal to 2. Add 3 to both sides, and I get z is equal to 5. So now I know y and I know z. I should be able to figure out x pretty easy. So let's use this equation. So I'm using the second. I have x plus, I know what z is, it's 5. So x plus 5 is equal to 6. Subtract 5 from both sides, I get x equals 1. All right, let's just check those a little bit and make sure they work. So we're saying that x is 1 and y is -3. So 1 plus -3, that's -2. That's good. X plus z should be 6. So we're saying that x is 1, z is 5, 1 plus 5 is 6, that works. Y plus z should be 2. We said that y is -3, z is 5, -3 plus 5 really is 2. So they all work and we have it solved. All right, so Jack is going to undertake a sequence of jumps. So he's going to start jumping, let's say in a straight line, one after the other. So on his first jump, he jumps 8 feet. That's a pretty long jump. All right, then on each sequence jump, he covers 3/4 the distance of the previous jump. So on his first jump, he goes 8 feet. On his second jump, he goes 3/4 of 8 feet. And then on the third jump, he would go 3/4 of that, and so on. So how much total distance had he covered after 5 jumps? So pause the video, see if you can figure that out. All right, so let's look at what's going on. So what we actually have here is a series. We're going to add up all of his jumps. So his first jump, he goes 8 feet. Then the second jump, he's going to go 3/4 of 8. So 3/4 of 8 is 24/4 is 6. So he goes 6 feet on his second jump. Now he's going to go 3/4 of 6, which would be 18/4, which would be 9/2, or 4.5. 18/4, 9/2, 4.5. All right, on the fourth jump, how far does he go? So we have 9/2 plus or times 3/4. All right, so that's 27/8 on this next jump. Plus, then on his fifth jump, he's going to go 3/4 of that. So 27/8 times 3/4. And we get, say, 27 times 3 is something. 27 times 3 is 81. I do that. We get 81/32. Okay, so there's his 5 jumps, and all we have to do is add those up. So you can pull out your calculator. Calculator will be allowed on this part of the test. 8 plus 6 plus 4.5 plus 27/8 plus 81 divided by 32. And I get 781 divided by 32, which is 24.40625 total feet. All right, let's solve this same problem a little different way. All right, so we could write this out in our sigma notation, or series notation. So we're going to go from k equals 1 up to 5. Those are my 5 jumps. My initial jump was 8 feet. My common ratio was 3/4. So I'll have 3/4 to the k minus 1 power. All right, so if I plug in 1 for k, 1 minus 1 is 0. 3/4 of 0 is 1, so I get 8 on the first. Plug in 2 for k, 2 minus 1 is 1. 3/4 to the first is 3/4. 8 times 3/4 is 6. And so on all the way up to 5. So this is just a shorthand way of writing what we have here. And then if you remember, we had a formula. So our formula was A times R to the n minus 1 over R minus 1, I believe. All right, so my initial was 8. My common ratio was 3/4. N is 3/4 to the 5th minus 1 all over 3/4 minus 1. And then I would have 8 times 3/4 to the 5th. Let's see, 3 divided by 4 raised to the 5th is some big number, minus 1. Now, I get some crazy number here, so I'm just going to type all this in my calculator. So when I put this in my calculator, divided by 0.25, I get, well, when I put all that in my calculator, I get the exact same thing I got over there. So 781 over 32. All right, so Jill deposits $2,000 in an account, and the account has an annual interest rate of 5%, compounded annually. Okay, so how much money would she have after 10 years? So pause the video, see if you can figure that out. All right, so let's have a look at it. Let's make a table. All right, so here's going to be the number of years, and here's going to be how much money she has. All right, so she starts out, let's call that year 0 when she starts. So she starts out with $2,000. All right, after the first year, how much money does she have? So after 1 year, the amount in her account has an interest rate of 5%, which is compounded. All right, so what that means is she's going to have the $2,000 plus 5% of $2,000. How do you figure out 5% of 2,000? Well, you multiply 2,000 times 0.05. So she's got the original $2,000 plus 5% of 2,000. So that's what it means to compound at 5%. All right, so let's think about this. So I could say that this is 2,000 times 1, right? 2,000 times 1 plus 2,000 times 0.05. If I factor the 2,000 out of this expression, I have 2,000 times 1 plus 0.05. So 1.05. So after the first year, she would have 2,000 times 1.05, which would be $2,100. $2,100. 100 is 5% of 2,000. All right, what about after 2 years? So now we're going to take this total amount that she has, so 2,000 times 1.05, and we're going to do this amount plus 5% of that amount. So what that means is we would multiply by another 1.05. So what she has in there, times it by 1.05, and that's her new amount. Okay, after 3 years, we would take this amount that she has, 1.05 times 1.05, and we would multiply by another 1.05. That would tell us how much she has. Then after 4 years, we would do 2,000 times 1.05, 1.05, 1.05. That's how much she has in there, and we would multiply by another 1.05. Okay, so you see what the pattern is, right? I'm doing 2,000 times 1.05 raised to the 1, 2, 3, 4, raised to the number of years. So after 10 years, she would have $2,000 times 1.05 raised to the 10th. And if we ask our calculator what that is, 2,000 times 1.05 raised to the 10th power, I get approximately $3,257.79. All right, so in general, to figure out this compounded interest, you take the So after n years, you're going to do the beginning amount. We'll call that A. And we're going to multiply it by 1 plus the interest rate. We'll call that R for interest. And you're going to raise that to the nth power. So it's really a simple formula. If your interest rate is 5%, the R would be 0.05. So 1 plus 0.05 is 1.05 raised to the 10th power times what you start with is 2,000, and that'll tell you how much is in your bank account. All right, so we have a piece of paper whose area is 100 square centimeters. All right, so then we cut that piece of paper in half, and then we take one of those halves and cut it in half. Take one of those, cut it in half, then one of those and cut it in half, and so on. I want you to find me a formula for the area of the smallest piece of paper after n cuts. All right, so see if you can figure that out. All right, so let's make a table here. So after so many cuts, I want to know what the area of the smallest piece is. All right, so where do we start? We'll start with 0 cuts. All right, what's the original area? Well, that's 100 square centimeters. After 1 cut, what's the area? It would be 50. After 2 cuts, we cut that one in half, so the area is now 25. After 3 cuts, it's 25 over 2. After 4 cuts, it would be 25 over 4, and so on. All right, so what is a formula for the nth cut? Okay, so what are we really doing here? So we're starting with 100. And we're doing 100 times 1/2, right? That gets us to 50. Okay, and then we're taking 50, which is 100 times 1/2, and we're multiplying it by half again. And so on. We're doing 100 times 1/2 times 1/2. That size paper, the 25, and we're multiplying it by half again. All right. So on. So after the 3rd cut, we had 100 times 1, 2, 3 halves, which is 100 times 1/2 to the 3rd. So after n cuts, we would have 100 times 1/2 to the nth power. All right. So a good formula would be area is equal to 100, the original value, times the common ratio to the nth power. Let's just check that out. So when n is 0, so after we've not made any cuts, 1/2 to the 0 is 1, we've got 100. After 1 cut, put in a 1 for n, 100 times 1/2 is 50. After 2 cuts, 1/2 squared is 1/4, 100 times 1/4 is 25, and so on. So there's our formula. All right, so see if you can find the solution to this quadratic equation. All right, so let's have a look. So remember, ways to solve a quadratic equation, we can do it by taking the square root of both sides if we can just get it solve for x squared, but we can't here because we have an x squared and an x term, so that won't work. We can factor, we can complete the square, or we can use the quadratic formula. Let's try to factor this. Okay, so I know I'm going to need a 3x squared, so I'll need a 3x and x. I know I'm going to need a 1, so I'm going to need a 1 and 1. If I have 3x squared, I have 3x and 1x. Okay, so that seems like it might be possible. I need a plus 1, so let's try a minus and a minus. So 3x squared minus 3x minus another x is minus 4x. So that won't work, and of course pluses won't work either. 3x squared is 3x, plus 1x is 4x, not going to work. All right, so let's use the quadratic formula. So remember, the quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Important that you know that. So we have x equals opposite of b, so that would be 2 plus or minus the square root of b squared, so negative 2 squared is 4, minus 4 times a is 3, and c is 1, all over 2 times a, which is 3. Let's simplify that. So x equals 2 plus or minus the square root. All right, 4 times 3 is 12. 12 times 1 is 12. So I have 4 minus 12 will get me negative 8 all over 6. All right, so I notice I have a negative number underneath the square root, so this is going to be imaginary. So I have x equals 2 plus or minus the square root of 8i all over 6. So square root of negative 8 is the square root of 8i. All right, we can simplify the square root of 8 by changing it into 4 times 2. So I've got the square root of 4 times the square root of 2 times I all over 6. 4 times 2 is 8, and then I can break it apart. Square root of 4 is square root of 2. The square root of 4 is 2. So now I have 2 plus or minus 2 square roots of 2 times I all over 6. Now I can simplify. I can divide everything by 2. So that'll be a 1 plus or minus. This becomes a 1. 2i all over 3. So those are my imaginary roots. All right, so here's a really easy question that you can get right. Over what interval, and I mean what interval of x, is this function decreasing? So when is the function decreasing? All right, so let's think about it. Is the function decreasing here? No, it's constant. It's staying the same. Here the function is increasing all the way up to here. Here the function is increasing. It's going up. Here the function is constant. So this function is decreasing on this interval, and it's also still decreasing on this interval. So this function is decreasing from b all the way to d. So on this whole interval from b to d, the function is decreasing. So we would write that like this in interval notation. Notice that we'll use parentheses because it's not actually decreasing at b, and it's not decreasing at d. It's kind of constant, where it is constant up there at b. It's constant down there at d. All right, so we have a circle here with a radius of 3 centimeters, and this arc length is 6 centimeters. So the distance around the circle from here to here is 6 centimeters. All right, I want to know the measure of angle theta in radians. All right, so remember the definition I gave you of radian. So say this is the radius r. This is theta. Remember, 1 radian is the angle such that this arc length from here to here is exactly the same as the radius r. So if this was, say, 5 centimeters, this distance would be 5 centimeters, and this would be 1 radian. So here, notice that we have a radius of 3 centimeters. So 1 radius, 1 radian, would be right in this area. So where this is 3, from here to here, that would be 1 radian. So if I go all the way around to 6 centimeters, that's obviously going to be 2 radians. So theta is equal to 2 radians. Right. You also have a little formula for arc length. S equals R times theta, where theta is measured in radians. So S is your arc length, R is the radius. So here my arc length was 6, my radius was 3. I wanted to know theta, so divided both sides by 3, and I get theta is equal to 2. All right, so here I've given you two functions, f of x equals x squared minus 4, and g of x is equal to negative, and in parentheses, x plus 2 squared. I want to know the intersection points of the graphs of those functions. So see if you can figure that out. All right, so if I want to know where these two graphs intersect, I should set the two functions equal to each other. So I want f of x equal to g of x. So I have x squared minus 4 equals negative x plus 2 squared. All right, how to solve that? So let's multiply out the x plus 2. So I've got x squared minus 4 is equal to negative. If I square something, it means to multiply it by itself. So I need to multiply x plus 2 times x plus 2. I have x squared minus 4 equals negative. All right, if I multiply this, I get x squared plus 2x plus another 2x, that's plus 4x plus 4. Right? And then it's minus all of that, so I've got to change all these signs to negative. So let's come up here. I have x squared minus 4 equals negative x squared minus 4x minus 4. All right, let's add 4 to both sides of this equation. So if I add 4 to this side and this side, those will just be gone. And let's add, I want to solve a quadratic equation, so let's get it set equal to 0. So I'm going to add x squared to both sides. That'll give me 2x squared. Add 4x to both sides, plus 4x equals 0. Divide both sides by 2. So x squared plus 2x equals 0. All right. I could use a quadratic formula, but I can factor this. I have a GCF of x, so I can factor out x, and that will leave me with x plus 2 equals 0. So if I multiply two things together and the answer is 0, then either one of those could be 0. So either x is equal to 0 or x plus 2 is equal to 0. So either x equals 0 or x equals negative 2. All right, but I want to know the intersection points. All I know is the x value. So to find the point, I'm going to plug 0 in for x, and I can plug it into either equation because that's where they intersect at. So if I put 0 in for x here, I get negative 4. Okay, so there's one point. If I plug negative 2 in for x, negative 2 squared is 4, 4 minus 4 is 0. So I get negative 2, 0. Notice that one is also a root. All right, what if I had to graph these? So maybe I could graph it on my calculator, or I can do this by hand pretty easy. All right, so this first one is x squared minus 4. So the minus 4 just shifts down. 1, 2, 3, 4. So I know I've got that. And I have a parabola. All right, where does it go through the x-axis at? Well, all I need to do is put in a 0 for the y. So if I put 0 here, I can add 4 to both sides. I have x squared is equal to 4, so x is going to be plus 2 or minus 2. This, and the plus 2 inside the parentheses, will shift the parabola left 2 spots and flip it upside down. So it's going to be a parabola that looks like that. Where does it go through the y-axis? So I could just put 0 in for x. 0 plus 2 is 2. 2 squared is 4, and I get negative 4. there, so that's where it goes through. It's an ugly looking parabola, but you know what I mean. All right, and you see we have two solutions. We have a solution at -2, 0, and we have a solution at 0, -4. Notice those are the two solutions that we got over there.